If there is one world in the solar system that dares to turn its back on everything, it is Uranus, a giant planet, lying almost completely on its side, 98 degrees, nearly overturned, while the other planets spin like orderly tops around the sun. Uranus lies there like something that was knocked down and chose to live differently. This is not just a gas giant, it is a colossal mystery. In 1781, a German-born musician living in England named William Herschel lifted his telescope toward the sky. He was not searching for fame. He was not trying to start a revolution. But that night, he noticed a faint point of light moving slowly. At first, he thought it was a comet, yet its orbit did not behave like one. He had just expanded the solar system. Uranus became the first planet discovered with a telescope, and marking the moment humanity realized the sky was not fixed and unchanging. For thousands of years, people believed there were only 6 planets. But out there, far beyond, a distant and frozen world had been orbiting silently all along. At an average distance of 2.87 billion kilometers from the Sun, Uranus takes 84 Earth years to complete a single orbit. Since its discovery, it has not even finished 3 full revolutions around the Sun. But what makes it extraordinary is not its distance. It is the way it exists. Uranus has an axial tilt of 97.77 degrees. In simple terms, it almost rolls along its orbit. Instead of spinning upright like Earth, it rotates like a ball pushed onto its side. The result? Its poles point directly at the Sun for 42 years at a time. Imagine 42 years of uninterrupted daylight, then 42 years of absolute darkness. No sunsets, no sunrises, only eras of light and eras of shadow. And the temperature, minus 224 degrees Celsius, the coldest planetary atmosphere in the solar system, even colder than Neptune, despite Neptune being farther away. Cold enough to freeze most gases. Its atmosphere is composed primarily of hydrogen, helium, and methane. That methane absorbs red light, giving Uranus its pale blue color, a shade so soft it feels almost unreal, eerily calm. But do not let that color deceive you. Uranus is a dynamical nightmare. Winds can reach speeds of 900 kilometers per hour. Massive storms appear and vanish like ghosts. When Voyager 2 flew past in 1986, the only spacecraft ever to visit, it transmitted images of a nearly featureless sphere. No great red spot like Jupiter, or no massive dark vortices like Neptune, just a mask of quiet. But later observations from the Hubble Space Telescope revealed something else. As Uranus approached its equinox, bright white storms erupted violently across its atmosphere. The weather system was never dead. It was waiting. Uranus has 13 faint rings, discovered in 1977 when astronomers observed a star being occulted. The starlight flickered before and after the planet passed in front of it. That flicker was no coincidence. It has rings, dark, narrow, and cold. It has 27 moons, named not after Greek or Roman gods, but after characters from Shakespeare and Alexander Pope: Titania, Oberon, Miranda, Ariel, Umbriel. Even in naming, Uranus rebels, carrying a touch of literature instead of mythology. Miranda, the strangest of them all, it looks as if it were torn apart and stitched back together. Its Verona Rupees cliff rises about 20 kilometers high. If you jumped from it, you would fall for nearly 12 minutes before hitting the surface. Its system is a stage of chaos. But an even deeper mystery remains. Why is it tilted? The most widely accepted theory suggests that billions of years ago, an object roughly the size of Earth slammed into Uranus. The collision was powerful enough to tip it over. Not destroy it, not tear it apart, just alter its destiny forever. If that is true, then every 42-year season, every alternating pole of light and darkness, every unusual orbital configuration of its moons, all are the legacy of a single impact, a cosmic accident that created a radically different world. Yet some scientists propose that not one, but multiple impacts gradually tilted it. Others suggest complex gravitational interactions with other giant planets during the solar system's chaotic youth. Uranus does not tell a story of stability. It tells a story of survival after violence. And what makes it most haunting is not the cold, not the tilt, not the strange blue color. It is the solitude. No spacecraft has returned since Voyager 2. No orbiter circles it. It remains at the dark edge of the solar system, billions of kilometers away, spinning sideways through decades-long nights. A giant planet, almost forgotten, but that silence is only the surface. Beneath the pale blue clouds may lie an ocean of water and ammonia, thousands of kilometers deep. Beneath that, a rocky core hotter than 5,000 degrees Celsius. Phenomena we have never witnessed may be unfolding there. And if we do not truly understand Uranus, then we do not truly understand how planets form, evolve, and are transformed. This 98-degree world is not merely an oddity. It may be the missing piece of the solar system's history, and what we discover next could reshape how humanity sees its place in the universe. The surface of Uranus looks like a calm, pale blue sphere, but beneath that layer of gas lies a structure unlike any other planet. Uranus is classified as an ice giant, different from Jupiter and Saturn, which are gas giants. The distinction is not just a poetic label. It reflects the fundamental nature of what the planet is made of. About 80% of Uranus's mass consists of a vast ice layer, tens of thousands of kilometers thick, but not ice as you know it, not solid frozen water. Instead, it is a mixture of water, ammonia, and methane existing under extreme pressure and temperature. A colossal ocean, dense, scorching, compressed beneath unimaginable force. Deep inside, pressure may reach millions of times Earth's atmospheric pressure. Temperatures rise to thousands of degrees Celsius. In those conditions, matter behaves in ways that are no longer familiar. Physical models suggest that inside Uranus, there may be diamond rain. When methane is subjected to enormous pressure, carbon atoms can separate and crystallize into solid diamonds, falling like rain through superheated fluid layers. It sounds like science fiction. Yet laboratory experiments on Earth have reproduced similar phenomena under simulated extreme conditions. A planet where diamonds may fall from the sky. But something even stranger lies in its magnetic field. Earth's magnetic field is relatively stable and originates near its central core. Jupiter's magnetic field is powerful and roughly aligned with its rotation axis. But Uranus's magnetic field is offset nearly 8,000 kilometers from the planet's center and tilted about 59 degrees relative to its rotational axis. It does not originate from the center. It seems to be generated in an outer, uneven, distorted layer. When Voyager 2 flew past in 1986, its instruments detected a warped, wobbling, twisted magnetic structure. If you were standing on one of Uranus's moons, the electromagnetic sky above you would shift constantly as the planet rotates on its side. The magnetic poles would sweep through space like a frantic searchlight. This creates a chaotic magnetosphere where high-energy particles are trapped in complex trajectories. Radiation belts exist, but they are asymmetrical and distorted. That distortion raises a profound question. Is Uranus's interior neatly layered as once believed, or is it a turbulent mixture? Recent research suggests it may possess a soft core, not as solid as older models proposed. The ancient collision that tilted the planet may not only have knocked it sideways, but also stirred its interior, trapping heat and preventing it from escaping efficiently. And that leads to another mystery. Uranus emits very little internal heat. Jupiter and Saturn radiate more heat than they receive from the Sun. Neptune does as well. But Uranus releases almost no excess heat. It is unusually cold. Why? One hypothesis suggests that the ancient impact caused much of its original thermal energy to dissipate. Another proposes that its internal structure blocks heat from rising to the surface. Or perhaps it simply formed differently. Its coldness is not just about distance. It is the aftermath of violence. Then there is its system of moons. And Miranda, a tiny world only about 470 kilometers across, has a surface that looks like it was stitched together from fragments. Towering cliffs, wrinkled plains, strange V-shaped structures. No other moon in the solar system looks like this. One theory suggests Miranda was once shattered by tidal forces, then reassembled. A world that died and rebuilt itself in distorted form. Ariel and Titania show signs of past geological activity. Vast canyons and fault lines stretching hundreds of kilometers. That suggests that in the past, internal heat was strong enough to melt ice within, driving tectonic movement. Umbriel, by contrast, is dark and barely reflective, like a chunk of coal drifting through space. The Uranian system is not quiet. It carries scars of motion, collision, and evolution. Its rings are nothing like Saturn's glittering bands. They are narrow, dark, composed of rocky and icy debris. Perhaps remnants of a shattered moon. Perhaps the product of millions of years of microscopic impacts. Everything orbiting this planet bears the mark of disruption. Then, in the early 21st century, as modern telescopes turned toward it, something remarkable emerged. As Uranus approached its equinox in 2007, astronomers recorded an increase in atmospheric activity. Bright cloud formations, powerful storms. The planet once thought to be too quiet revealed itself as dynamically alive. Its 98-degree tilt produces the most extreme seasons in the solar system. When one pole faces the sun for 42 years, energy accumulates slowly. When the angle shifts, temperature contrasts trigger violent wind systems. This planet is not dead. It simply moves on a timescale far slower than ours. One orbit around the sun takes 84 years. A single season lasts 21 years. Every transformation is generational. We observe it for a few decades and assume it is static. But on its own timescale, Uranus is a stage of ongoing change. As scientists discuss a new mission, a dedicated orbiter designed to study Uranus for years, they are not merely seeking clearer images. They want to decode its deep internal structure. They want to understand why its magnetic field is so distorted. They want to know whether its deep oceans allow complex chemistry to unfold. Because ice giants are not rare in the universe. Exoplanet discoveries show that many worlds roughly the size of Uranus and Neptune orbit other stars. If we do not understand Uranus, we fail to understand a vast portion of planetary systems beyond our own. A forgotten planet at the edge of the solar system may be the key to understanding billions of other worlds. And its mystery is far from over. More than 35 years have passed since Voyager 2 swept past Uranus. One single encounter, one fleeting glimpse, and then silence. No orbiter, no lander, no atmospheric probe. A giant planet left behind in the cold darkness at the edge of the solar system, while humanity fixed its gaze on Mars, Jupiter, and Saturn. Yet the data Voyager 2 collected, limited as it was, proved unsettling enough to keep scientists awake. A strangely distorted magnetic field, almost no internal heat, an interior structure still unconfirmed, a bizarre moon system, dark, narrow rings. It all felt like a rough draft of a much larger story. And over the past decade, the scientific community has grown louder about one thing. It is time to return. In 2022, in the US, the National Academy's Decadal Survey, the document that guides major space missions, a standout proposal rose to the top: the Uranus Orbiter and Probe, a dedicated spacecraft and atmospheric entry probe designed to travel to Uranus, enter orbit, and study it for years. Not a flyby, not a few snapshots before disappearing into deep space, but to stay. Preliminary plans suggest a launch in the early 2030s, using gravity assists to shorten a journey that would still take more than a decade. If all goes well, humanity could have an orbiter around Uranus in the 2040s, more than half a century after Voyager 2. Why so long? Because distance is unforgiving. more than 2.8 billion kilometers away. Light itself takes nearly 3 hours to travel from Earth to Uranus. Every command sent is an exercise in patience. Solar energy at that distance is so weak that traditional solar panels are nearly useless. The spacecraft must rely on nuclear power. The cost is enormous. The weight stretches across generations of scientists. But the reward could redraw the map of our understanding. An orbiter could map the magnetic field over time, watching how it shifts with the seasons. An atmospheric probe could plunge into the pale blue clouds, directly measuring chemical composition, isotopic ratios, wind structure at depth. Those measurements would reveal where the planet formed in the primordial protoplanetary disk and whether it migrated from another region long ago. Some theories suggest that the giant planets once moved significantly after forming, reshaping the entire early solar system. And if Uranus and Neptune once swapped places, or were pushed outward by gravitational interactions with Jupiter, then our history was far more chaotic than the calm architecture we see today. To understand Uranus is to understand that violence. And there is an even greater reason. Among the thousands of exoplanets discovered so far, the most common type is not rocky worlds like Earth, nor gas giants like Jupiter. It is planets between the size of Earth and Neptune, often called mini-Neptunes or sub-Neptunes. They resemble Uranus more than anything else in our solar system. If we do not understand how an ice giant works, we remain blind to a vast portion of the planets in our galaxy. Beneath those pale methane clouds may lie clues to prebiotic chemistry in high-pressure oceans, data that explains how magnetic fields form in exotic, ionized fluid layers, answers to why some planets retain thick atmospheres while others are stripped bare. And perhaps deeper still, a story about the fragility of order. A single impact billions of years ago tilted an entire world, a brief event on cosmic timescales that determined there would be 42 years of sunlight, 42 years of darkness, decades-long seasons, a warped magnetic field, and a strange family of moons. The universe does not need to be fair to create beauty. Uranus is not as loud as Jupiter, not as dazzling as Saturn's rings, not as dramatically deep blue as Neptune. It is cold, distant, quiet, yet that quiet hides a world bent by history. A planet tilted 98 degrees, spinning once every 17 hours and 14 minutes, circling the sun for 84 years to complete a single year, carrying 27 literary moons, dark rings, and a core no one has ever touched. At the edge of the solar system, it keeps turning, and we, on a small planet billions of kilometers away, are trying to piece together its story from faint signals crossing the depths of space. Perhaps in a few decades, when a new orbiter begins sending back sharp, detailed images, we will finally witness true storms raging across its atmosphere. Perhaps we will confirm diamond rain. Perhaps we will understand why it is colder than a planet even farther from the sun. Or perhaps, as so often in the history of exploration, we will discover that we were wrong about almost everything. Uranus is not just a pale blue dot in a telescope. It is a reminder that the universe is always more complex than our intuition. And if an entire world can be tilted nearly 100 degrees by a single collision, then every order we see today is only a temporary arrangement born from billions of years of chaos. Now imagine this. Out there in our galaxy are hundreds of billions of stars and countless other Uranuses, tilted, frozen, carrying secrets no one has ever seen. What do you think lies deepest beneath those blue clouds? Diamond rain? A strange ocean? Or something entirely different? Something we have not yet dared to imagine? Leave your thoughts in the comments below. And if you want to keep exploring the strangest worlds in the universe, don't forget to subscribe. This journey is only just beginning.